Hello, Math 1 students. So, 1.g is I can simplify expressions using multiple laws of exponents, right? And with this brings everything in this chapter together, right? So, you really have to know your properties inside and out. So, the first property we have is when we multiply same bases. What do we do when we multiply same bases? We add the exponents. When we raise a power to a power, what do? We multiply the exponents. Now here, the product of a power property is a combination of the power to a power property, right, and this new property. Everything in this quantity is being raised to the p power. So this would be a to the m times p and b to the n times p. Okay? So you have to know when to use each of these properties. We know quotient of a power's property, right? We know right away we can just go ahead and subtract those powers, but you can also use the canceling technique if you had to. Power of a quotient property, I'm raising everything in that quantity to the n power. And if I have, x to the a over y to the b, all raised to the n power, again, I'm multiplying the powers of powers. So a times m over y to the b times m. If my negative exponent's in the numerator, I bring it to the denominator to make it positive. If my negative exponent's in the denominator, I bring it up to make that exponent positive. And then we know anything to the 0 power is always going to equal 1. So let's go ahead and do a couple of examples where we're using a multiple properties in one problem. So after you know all of the properties, when I look at this first example, I know right away in this quantity I have to raise everything to the third power. In this quantity, everything to the second power. When I raise a power to a power, what do I do with the exponents? I multiply. So x to the 2 times 3 is 6. Y to the 3 times 3 is 9. Z to the 5 times 3 would be z to the 15th. Times x to the 3rd to the 2nd is x to the 6th. Y to the 10th. Z to the 2nd. So now, once I'm done with my power to a power property, now I can go ahead, multiply the x's together. But remember, when I multiply same bases, this is where I add the exponents. So x to the 6 plus 6 would be x to the 12. Y to the 9th times y to the 10th would be y to the 9 plus 10, which is y to the 19th power. Then z to the 15th times z to the 2nd would be z to the 15 plus 2, which is z to the 17th power. Okay? Now the next one, if I look at this, not raising this, so this just could be 7k to the 2nd times, I'm not raising this to any power, so it's negative 2k. But when I raise everything in here to the 0 power, what's that become? Just 1. So now, I'm going to multiply the coefficients, right? 7 times negative 2 is going to give me negative 14. And then k to the 2nd times k would give me k to the 2 plus 3, or 2 plus 1, which is 3. All right? And remember, when you multiply by 1, it doesn't change anything. Number 3. Technically, this is all over 1 right now. And now, before I do anything, the first thing I'm going to do is move my negative exponents. A to negative 3 is going to come down. A to the 2nd is going to stay up top. A to negative 4 is going to come down. So my first step was to get rid of negative exponents. Now, if I look, I have a to the 2nd up top, and then in my denominator, I'm going to have a to the 3rd times a to the 4th, which is a to the 3 plus 4 So it gives me a to the 7th power. Now, if I have nothing left here, right? If I look, I have 2 a's up top, 7 on bottom. Cross 2 out. If I take 2 off the bottom, how many do I have left? 5. If I have nothing left up top, it's 1 over a to the 5th power. So the next one, I'm going to do the power to a power here. Multiply these exponents to get k to the negative 6 times k to the 4th. Right away, I'm going to get rid of my negative exponent. So I have k to the negative 6 comes down. K to the 4th stays up top. And now if I go to simplify that, 4k's off the top. If I take 4 off the bottom, how many do I have left? 2. So I have 1 over k to the 2nd power. Number 5. You have to understand that first thing I'm going to do, power to a power here, raise everything to the 2nd power, raise everything to the 3rd power, raise everything to the 6th power. Okay? So right away, 6 to the 2nd, 36, x to the 6th, y to the 8th. Then this is going to be times x to the 2nd to the 3rd would be x to the 6th. Y to the 5th to the 3rd is y to the 15th. All over. 2 to the 6th power is going to be 64 x to the 30th power, y to the 60th power. What I like to do next is real quick get this reduce this fraction out of the way. I know both of 36 over 64, both of these can be divided by 4. That would give me 9 over 16. Now, when I look in my numerator, I have x's here. So when I add those exponents, I'm going to get x to the 12th. If I look at my y's, right, in the numerator, it's going to give me y to the 21st power over x to the 30th, y to the 60th. Now, from here, I'm left with 9 over 16. And when I look at my x's, 12 in the numerator, 30 in the denominator, cancel all 12 off the top. If I take 12 off the bottom, 30 minus 12 would be x to the 18th power. Then if I have 21 y's up top, 60 on bottom, cancel all 21 out. If I take 21 off here, I have 39 left. So y to the 39th power. Okay. Now, this one, 4a to the 5th stays, so 4a to the 5th power. Then I have times a to the negative 1 times 3 would be a to the negative 3. All over a to negative 2 times negative 2 is a to the positive 4. Now, some people will multiply these across and say 4a to the 5 plus negative 3, which is 4a to the 2nd. But I've tried to stay pretty consistent about get rid of negative exponents. 4 is going to stay. A to the 5th is going to stay. A to negative 3 is going to go down. A to the 4th is going to stay. So that would give me 4a to the 5th over. When I combine these, I'm going to add the exponents, and it gives me a to the 7th power. Now, if I simplify my last step, it's going to be 4. Take 5a's off the top. If I take 5 off the bottom, how many do I have left? 2. So 4a over a to the 2nd. Now this last example, right? This can kind of get chaotic, but I'm going to raise everything here to the 2nd power. 2 to the 2nd power is 4. M to the 2nd is m to the 4th. P to the 6th. So I've simplified this. Next one, 4 times 4 to the negative 2. M to the negative 4. P to the negative 2. all over negative 3 to the negative 1. So negative 3 to the negative 1, m to the negative 1, p to the negative 4 times 2 to the third, and I'm just going to simplify that to 8. M to the third is m to the ninth, then p to the 12th. Now I have some simplifying to do. First thing I'm going to do is get rid of negative exponents. So that's going to stay. So 4 stays, m to the 4th stays, p to the 6th stays. 4 to the negative 2 comes down below. M to the negative 4 comes down. P to the negative 2 goes down. 3 to the negative 1 comes up. M to the negative 1 comes up. P to the negative 4 comes up. 8 stays. M to the 9th stays. P to the 12th stays. So now I'm going to multiply across in my numerators, right? So if I look at this, 4 times 3 would give me 12. So when I multiply these together, it gives me 12. M to the 4 times m is going to give me m to the 5th, because I add the exponents here. P to the 6 plus 4 is p to the 10th. All over 4 squared is 16. Then 16 times 8 will give me 128. M to the 4 times m to the 9th is m to the 13th. P to the 2nd times p to the 12th is p to the 14th. Now, if I notice, I could reduce 12 over 128. And if I reduce that, I could divide both of these by 4. And when I do that, I would get 3 over 32. If I have 5 m's up top, 13 down below, take 5 off the top, 5 off the bottom, I have 8 left down below. P to the 10th, 10 p's cancel out. If I take 10 off the bottom, I get 4 left, p to the 4th. And I am done. All right, do me a favor, go ahead and check, right, or complete the next worksheet and let us know if you have questions.